This video is going to take a look at the implementation file for animal, and it will also take a look at the other header and implementation files before we get to the driver that uses pointers. So we just got done looking at the animal header file. We're just going to look at the implementation. It should be pretty straightforward here. So if I open up animal.cpp, it is going to show us the typical getters and setters and code that goes along with that. Please notice that you have to pound include animal.h. So in the .cpp file that accompanies the header file for animal.h, you need to make sure that you pound include animal.h in quotes. And we have our constructor that assigns the name and the weight, and we also assign the food variable a value of 0, and that's because we start off with 0 food and for each day for each animal. And we have our typical getters that just return values, and we have our setters that are going to set values, and then we have our feeding routine. And when we feed an animal, what we're going to do is just add to the weight of the animal, and we are going to add the total amount of food that was consumed. So we're just going to add to those two values as we feed the animal. And then please notice our get info. This is our generic or our base class get info. So every animal will be printed with an animal, a weight, and the food eaten for the week. Also, typically we don't put anything inside a destructor. Typically you won't have this line of code right here. I'm going to comment that out for just a second. But we want to put that in here so that you guys can actually see that the animal was destructed when it comes through. So when you actually write your code for yours, you won't have anything inside here. You do need the destructor. You do need to write this code in the implementation file, in the .cpp file, but you will not have this output line. Our mammal and our mammal.cpp classes aren't going to be a whole lot different. So if we just take a look at mammal.h, we have in mammal.h, we have one additional instance field that's private. And the person that wrote this code had the style where they put all of their methods first and then they put their class variables second. I'm going to go ahead and switch that around. And so I have my class level variable first. It doesn't matter what order those are in. That's a style preference. And so I have my class level variable is going to be an animal type. And remember that was from an enumerated type. I should also just highlight that we are in mammal.h. And in order to show inheritance, you need to use this colon. And then you want to specify the level of inheritance. We're going to inherit public, and then the name of the class that you are inheriting from. And in order to use that, you also need to pound include animal.h in your subclass. So whenever you inherit from a superclass, you need to pound include the superclass. So this will be the superclass that you pound include here. And you also need to make sure that you specify whether you're going to accept that, what type of inheritance you are accepting. So this specifier could be public or protected. If you don't place it in there, I believe it's private by default, and we had some errors in somebody's program, and that was the mistake, was that we forgot to put public here. So make sure that you include that specifier. And just notice we have a constructor and we have a destructor, and we are going to write a get info method for the mammal, and we're also going to have a get animal type method. Please notice it's returning an animal type underscore, and that goes back to the enumerated type that we declared in animal.h. And so it's returning, if we take a look, it's returning this type of data. And so that's why you see that capitalized animal underscore type. That's what that's referring to. Our implementation for the mammal, if we take a look at that, mammal.cpp, not much has changed except the following. It's the .cpp for the mammal header, so you need to pound include mammal.h. This line of code is kind of critical. Remember, you always have to include the name of the class and then the name of the method. So we always have the scope resolution operator on every single method that's in a subclass, or in the implementation file, not the subclass, but the implementation file. Also notice that I'm passing in a name and a weight, but then I don't actually have any code here in my constructor. And that's because I use the base class constructor right here, animal, name, and weight. So it's going to call the animal constructor, it's going to pass it the name and the weight. And then I don't have any code in here because this particular style is using a little shortcut to define the animal type right here. And so this is assigning that class level variable animal type, animal, to be a mammal. Please notice that's also from, it's also using the superclass here when it's using that. And down here, please notice also the animal class here is being called instead of the mammal class, because that's it was, if we go way back, that was our virtual void method. Last but not least, we're going to take a look at reptile. And reptiles, very similar to mammal, except we add in another private instance field. I like to have my class level variables placed first, so I'm going to place those class level variables first. Again, it really doesn't matter, that's just my style. And notice that we're returning an animal type here when we get the animal. Notice that we used animal.h here, again, because we're inheriting from animal, so we have to include that superclass here. So again, this is from the superclass. And otherwise, it's looking pretty much the same. Just mention again, you always have the very first line in your header files as a pragma once. And then the reptile.cpp, not too many surprises here, but again, take a look. We pound include reptile.h. Sorry for that error message. And the constructor uses, it's going to use, it passes in a name, a weight, and a temperature. We now have a third variable here. We use the superclass constructor to set the name and the weight. And then we use this little shortcut notation here to set the temperature. So this shortcut notation is taking the place of doing something like underscore temperature is assigned temp. It's just a shortcut notation. So I could accomplish the same thing. I could take and delete this and use this instead if I wanted to. But this is just a little shortcut method for setting your instance fields. And that's just a particular style of the person that helped me put this together. Get info has changed just a little bit. We are using animal type. We're going to output the animal type. We are going to get info from animal, which means it's going to call on the superclass and follow the code for the superclass. So if we looked at the animal.cpp, remember our get info there just has the animal name, weight, and food. So in the reptile, it's going to substitute in when we call that. The reptile is going to do name, weight, and food in here. And then we have this additional line of code that is going to output the temperature for the reptile. So this is an overloaded method. It's called exactly the same. And so it doesn't know whether it's going to call an animal or a reptile or a mammal until the code is running. And so it determines on the fly which get info method to use. Because the object that's using this one is going to be a reptile, it will print this information for the reptile. We do have a change temperature, which is different in the reptile because we need to check the temperature in the cage and changing it accordingly. And again, this return animal type is going to call upon the superclass because of the fact that it was a virtual. And we have our destructor. Again, destructor normally doesn't have a comment in it, but we put that comment in there so you could see when we run the code that when I destruct a mammal, it also destructs an animal. And likewise, when I destruct a reptile, it's going to destruct an animal. So what you're seeing here, destructing reptile, is this line of code right here in our output. So typically, you don't have that in there, but it's just showing you how the destructors actually work and what it's going to do when we use the polymorphism. That's going to conclude this video. The next one we'll take a look at the driver program, which uses pointers.